This is a pre-calculus little lesson on reviewing some factoring and then getting into a little bit of new factoring. So in these examples we're asked to factor completely. The first one, hopefully somewhat straightforward. First thing you should look for when you're factoring is the greatest common factor. So I look at these two things and they both have an a squared in them, they both have a b in them, and they both have a c to the fifth, leaving me with, out of that first term, the a's are done, the b's are done, and I would have only a c squared left. In the second term, I would have a squared b. I look at what I have left over in the brackets and it doesn't factor, and so that means I'm done. So always in any question look for greatest common factor as the first step in trying to factor any problem. Next classic Math 10 problem here is I've got x squared minus 10x plus 24. I look, there's no common factor for three terms, so I can't do it the same way I did in the one above, but hopefully you remember looking for two magic numbers here, two numbers that need to multiply together to equal positive 24, but they need to add together to equal negative 10, and if you look for those two numbers, hopefully you see them as negative 6 and negative 6 and negative 4, sorry. And so if you do that, you're going to have x minus 6 times x minus 4. If you're not sure in any kind of factoring, you can always multiply your factors back together and see if it ends up giving you what you had expected. In this case, you get x squared minus 4x minus 6x plus 24, which is x squared minus 10x plus 24. The same was true above. If we would have multiplied it back together, we would end up with the original expression. Now the next one is a slightly more difficult one, and although maybe it was a Math 10 problem, it was probably the hardest thing for most people in Math 10, and that is factoring these trinomials that have a coefficient in front of the x squared. Once again, look for the first thing possible, which would be a common factor, but there isn't one here. So I need to, again, look for my magic numbers, but in this case I'm saying what two numbers multiply together to equal negative 12 and add together to equal negative 1. And so my two magic numbers, hopefully, are negative 4 and positive 3, negative 4, positive 3. So what do I do with those two numbers? I say, well, this is 6x squared minus 4x plus 3x minus 2. Now, have I factored it? No. I haven't changed the value of it, though, either, because negative 4x plus 3x is still negative 1x. But when I look at this four terms now, I can factor them 2 and 2, meaning that these first two terms I can take out a 2x, leaving me with 3x minus 2. The second two terms don't have a common factor, so all I can take out is a 1 essentially, and I'm left with 3x minus 2. So if those two things in the brackets there are the same, we've done this thing correctly. You end up with 3x minus 2 times 2x plus 1. With these ones, and that's the method called decomposition. There are some others you may have learned at some point along the way, but that is the most common one that's taught. Again, if you FOIL it out, you'll get 6x squared minus 4x plus 3x minus 2. And you'll end up back where you started. Another one that's a review factoring question is this straightforward difference of squares. If you recall, difference of squares factors as two conjugate factors, a minus b times a plus b. Again, if you FOIL it out, expand it out, you get a squared minus ab plus ab minus b squared, and those two middle terms cancel, and you get a squared minus b squared. So to show you another example of that, if I had 81 m to the 4 minus 16n squared, I say, okay, well, these are no common factors, but they are perfect squares. First one, 9m squared, 9m squared, and the second one, 4n. If I put a minus in one bracket, a plus in the other, you can try expanding it, and you'll end up with the factors, or with the expression you started with.